Hi, Steph. Can say it's Steph in English?
Steven.
Steven, okay. So, we are at PDC today.
Yep.
We are pleased to be here with you.
Oh, I'm excited to be here with you too.
Thank you very much. And first, can you describe your job at Microsoft?
Sure. So my position, I'm a lead program manager on the parallel computing platform team. And my role is largely around designing and helping to implement and work out what the parallel systems that we build should be. So I spend a lot of my time talking with customers. I spend a lot of my time working through requirements. I spend a lot of my time actually figuring out what the APIs we build should look like, and then working through the functionality of them and how they should actually behave.
Great. My second question is about the parallel computing initiative. It was defined a few years ago. For your opinion, have you achieved your goals?
I think so. You know, we set out with Visual Studio 2010 to kind of do the first wave of parallel technologies out of Microsoft. We certainly haven't achieved the end-all, be-all of parallel computing, but we never set out to for this release. We really set out to make it significantly easier for developers to build applications that scaled up on multi-many-core hardware, and to make it significantly easier to reduce a lot of the boilerplate that developers would have to write. And I definitely think we've achieved that. If you look at technologies like parallel link, where you have a link query, a link to objects query, and you're able to add .as parallel, and under the covers we're able to replumb the system in order to take advantage of parallelism without the developer having to explicitly spin up threads, worry about locks and the like. So it's I'm very pleased with where we've ended up.
And about TPL?
Yeah, and the task parallel library as well, with parallel for each, and then with the lower level task constructs really representing arbitrary asynchronous operations and being able to coordinate work between them, use them to decompose parallel algorithms, parallel workloads into smaller pieces, expressing dependencies, having data flow. It's a pretty impressive system, if I may say so.
And tools.
And tools as well, absolutely. So the new concurrency visualizer and the new parallel stacks and parallel task window. So from a debugging perspective, being able to see all the tasks in your application, what's currently running, what's currently waiting, what it's waiting on, tasks that have been scheduled in the system, being able to see deadlocks, to break into the debugger and see that these two tasks are deadlocking and what they're deadlocked on. In the parallel stacks window, being able to visualize all of your threads at the same time, see their relations, being able to root out problems very quickly just by spotting them and what the various call stacks are, very useful. And then the concurrency visualizer, being able to understand over the lifetime of your application how much CPU was being utilized, what all your threads were doing, where they were executing, and so forth. Very cool technology.
Great. There is some incubation technologies like Axiom and STM, software transaction memory. When we will see this technology integrated in VS by default?
So it depends on the technology, and it depends on a few things. One, on how fast it takes for us to mature the technologies, as well as how much of a demand the Microsoft customer base has for things.
Okay.
I think with things like Axiom, there's a real need for language support for asynchrony and message passing and isolation. But I think it's going to take customers telling us the same thing for us to invest the necessary resources to bring some aspect of that to market.
Okay, but we can see this, for example, Axiom is the release of this version.
It won't be in Visual Studio 2010.
Parallel pattern is without doubt essential for the development of easily parallelizable apps. You have written a paper last week about that. And I noticed there is some extra code called parallel programming with .NET 4 Beta 2 sample. For me, it's very useful.
Good, I'm glad.
Do you plan to integrate it in official framework?
The samples?
Yeah.
So a lot of the samples came about because there are things that either we wanted to put into this release but didn't have time to do, or that we wanted feedback on. We wanted to vet some of the ideas before putting them in. So I certainly expect there's the potential for some of them to find their way into the framework in the future. But again, that really depends on what people ask for.
Okay.
And having them as samples allows people to play with them and incorporate them into their own applications without having to be in the framework.
Next question is parallel development is easier with Visual Studio, but it's still difficult for masses. Have you any ideas on how to improve the parallel experience for the future?
Right. So, and we still, with this release of Visual Studio 2010, we still expect that folks need to understand sort of the principles of multi-threading and multiple things happening at the same time, knowing about race conditions and the like. For sort of the masses to be able to develop with this, or with parallel computing, we really do need improved models that eliminate a lot of the need to understand sort of that lower level infrastructure. I think we start to see that with things like Axum, where you program in terms of with things like Axum, being able to create these individual agents that simply communicate their message passing.
Yeah, like Erlang, in fact.
Like Erlang, exactly. That model is one that is easier to reason about than what hundreds of components that are all reading and writing from the same shared memory.
Yeah.
So I think it's going to take things like that to bring this into the realm where everyone is able to take advantage of it. That and having components that are themselves parallelized internally that then others can just consume, and like any other library.
Do you think parallel technologies are opportunities for web developers? For example, Silverlight 4?
So for web developers, a lot of times with ASP.NET applications, with many sites there's just enough incoming requests to saturate the box. It's already very highly concurrent. And in that regard, there's typically not a whole lot of additional work that you necessarily have to spread around. However, there are many scenarios, especially for sort of back-end server, where there are lots of computationally intensive processes that you do want to parallelize. And even in websites that at certain times of day the traffic might be less than others and may not be saturating the box, at those points of the day it may be worthwhile to be able to spread your workload out across your server. So that's one of the reasons why on the .NET side of things, for example, we put a lot of effort into building by default these parallelism constructs on top of the same thread pool that ASP.NET is using, so that the resources are shared between them.
Cool. Currently, GPU developers ask for solutions to address CPU and GPU. Do you have some news about that?
So the best thing from Microsoft right now for GPU is the direct compute support in Windows 7.
It's in native language.
Yeah, in native, yeah. So there's nothing right now that's shipped from Microsoft for writing the GPU from managed code. However, the Accelerator team, which is out of Microsoft Research, did just release a new version of their Accelerator project, which allows you to target GPU from managed code and native code on sort of a higher level of abstraction.
Okay, Steve, thank you very much. It was very great for me to make this interview, and I hope for the next PDC to relaunch an interview with you.
That'd be great.
Thank you very much.
Thank you.
Thank you.